Okay, welcome back, students. So we're moving on to section B now of the 2020 paper. So a few things about section B and section A. So section A, the questions are worth 5 marks each, 25 marks each. Okay, for any of the questions you've been doing so far, we've always seen that they're worth 25 marks. Okay, well, once you go into section B, there'll be usually 2, sometimes 3 questions, and they're worth 50 marks each. So they're worth twice as much. And one of the reasons they're worth twice as much is because they're harder. They involve contexts, which is they're more embedded in a real world situation. And another word for that is applications. They're the application of maths in the real world. Okay, which takes a little bit more thinking and a bit more problem solving, and for that reason they're worth more marks. So you should keep that in account when we're doing them. We expect them to be more difficult, but they're also worth a lot more marks, so you should give them more time and be prepared to work on them for longer. Okay, let's jump straight in. And just really keep that in mind. We're going to see from the very beginning that there's an extra twist and that you need more thoughtful thinking. I'll show you exactly what I mean in this question. So Laura lives in Sligo with her parents and twin brothers. Okay, so you have Laura and 2 brothers, for instance, is an important part of that. The sum of the ages of Laura and her twin brothers is 44. Now, how many ages are we adding up? We're adding up twin brother A, twin brother B, and Laura. Okay, so we're adding up 3 ages and we're getting 44. But 2 of those ages are the same. So if we're going to try to use algebra, we will talk about L for Laura's age and B for the brother's age. And we will say Laura plus twice the brother's age equals 44. Okay. Now in 6 years' time, each of the brothers will be 20 years of age. So the brothers have an age of B, and when you add 6 years to it, they will be 20. Now you could do this without the algebra that I just wrote down. You could use common sense to see through the question. What age are they now? So here's a way of thinking about this and getting access to the problem. What age are they now if in 6 years' time they'll be 20? Most of us can do that in our head. The answer is 14. Okay, similarly, if we take 6 away from both sides here, we get that the brother's age equals 14. Okay, now we're going to go up to the top equation here and write it out with substitution. So we're going to have Laura plus double the brother's age, which is 2 times 14, equals 44. So Laura plus 28 equals 44. Now I'm going to take 28 away from both sides, and I'm going to use my calculator for that. If it ever loads. 44 minus 28 is 16. Okay, so that means Laura's age is 16. And we have to check now what we were asked. What age will Laura be in 6 years' time? Nasty. And this is where your 50 marks are earned. So there's 2 things there. There was the fact that there was the 2 brothers made it kind of confusing. And then there was the fact that there's a sting in the question. So I'm warning you, to be aware that you've got to be on guard for tricks in this part of the paper. Okay, so Laura in 6 years' time, it's 16 plus 6. If I hit just plus now, it'll assume I'm adding to the answer. And it's 22. So she'll be 22 years of age. I'll put a box around that, and that'll give me full marks. Okay, so Laura's family travel to Dublin for the day. Laura must decide what to wear. She can choose from 5 tops, 3 pairs of jeans and 2 pairs of runners. How many different outfits, a top, a pair of jeans and a pair of runners, can she choose for the trip? Okay, so this is a pretty straightforward application of the fundamental principle of counting. Okay, which says if you have different things you can do, and you want to count how many there are in total, you just multiply the numbers. Okay, so we're just going to multiply 5 by 3. Sorry, I nearly obliterated the numbers on you there. 5, I did it again there. 5, 3, and 2. So we multiply those numbers together in the calculator. 10 times 3, and we get 30. Okay, so she has 30 outfits in total. Now that was a simple enough application. That could have belonged in section A of the paper. Okay. Now what 30 outfits. Now you probably get away without putting that in, but just in case we put in the units of measure or outfits. Okay, we'll go on to the next question. The family leave their home at 7:20 a.m. So early in the morning they leave at 7:20 and they arrive in Dublin at 9:50. And the distance from Sligo to Dublin is 210 kilometers. Find their speed. Okay, now the formula for speed is often, and the various equations is often given in this triangle. D is for distance, S is for speed, and T is for time. Now, people sometimes remember those letters as DADS, simple, triangle. Okay, because D, S, and T are in the equation. But the triangle isn't an equation, and so we do want to be able to write down an equation as well. So what the triangle really contains 3 equations. If you want a distance, we'd multiply these 2 together. But that's not what we need here. If we want speed, you would say speed equals, and you would see there's a fraction here. So speed equals distance over time is really the equation we want to use. Okay, and it's preferred mathematically to the triangle, which isn't an equation and doesn't have an equals in it. So it doesn't really matter which you use or if you use both, as long as you get it right. Okay, so the distance we already know. We're going to substitute in 210 kilometers. So now we need to get to time, but we need to be careful about the units of time, and they do talk about hours here. So when we're working with the time, kilometers are already in the correct unit, but when we're working with the time, we want to come out with hours. So let's do a subtraction vertically. We have 950 is the final value, take away 720. Okay, now 20 away from 50 is 30 minutes, and 9 take away 7 is 2. So we need to write 230 in as hours. So 30 minutes is a half an hour. So it's 2.5. So turning that into a decimal, we have 2.5. And we shouldn't be amazed that we have to do something kind of challenging and difficult like that. Remember, we're in section B. We're in the second part of the paper. So we've 210 divided by 2.5. And that's in hours. And we put that in the calculator. Clear with the AC button. Fraction bar, 210 kilometers and 2.5. Okay, I'll hit the fraction bar now, and 2.5 hours. Okay, so the speed in kilometers per hour is 84. That makes sense. That's the type of speed a car could travel at, kilometers per hour. Okay, you might know that in a motorway the speed limit is 120 for most of the motorway. I'm not too sure about the road from Sligo to Dublin, but 84 sounds perfectly reasonable. Now again, in section B you want to be checking your answers for being reasonable, because there's problem solving behind everything you do here. Okay, I'm moving on with the rest of the question. And don't be surprised if the questions go on for much longer. After all, you're getting twice as many marks for them. While in Dublin, they visit a small rectangular park with a circular pond in the centre. Okay, so let's get a sense of what's going on here. So this is the park. And the pond in the middle might be made out with water in it, but I've just obliterated the detail there. Okay, so there's the pond in the middle. Okay, we get it? I hope so. And there is some more information here with distances. The length of the diagonal from A to C is 130. And that would be shooting through, straight through the middle of the pond, is 130 meters. And the lines on the diagram below show all the paths in the park. Now the word path there is probably a mathematical path. Or no, I think you can come through, yeah, you can go along here and come around here. So these lines are paths. There's a path this way and there's a path this way. Okay. Now we haven't even started the question yet. Here comes the first part, the first question. Laura and her parents walked through the park from A to E and then around the pond from E to F, could be either direction, and continue on to C. Now my understanding of it is they don't go around all the way around the pond. My understanding of it is that they go around, but you have to be careful with the words. Then around the pond from E to F and continue on. Then around the side of the pond, I would have said they don't circle the pond. I would hope not anyway. I'm going to look at something really quickly on the marking scheme. Yeah, they talk about a semicircle. But there is room for confusion there, and you could say, well, if you're going to go around the pond, you should go around the pond. But I'm just picking at the wording, and sometimes you do have to kind of interpret the wording, but mostly it's pretty clear. They do say and continue on to C. So yeah, our interpretation, which is correct because I've just had a quick little sneaky look at the marking scheme, it is that they go along here, down around here, and on like this. Okay, so find out how far it is. So we could break it up. Now this is part of problem solving. In problem solving, you want to break up your problem into pieces. So we would, into logical kind of ways. So we want this bit. So we're kind of deconstructing the question. We think about how long is this bit, these two strips here. Well, they're not 130, they're 130 take away 20, which is 110. Okay, and the second then part of the question is how long is this bit? Now that's a semicircle. So we're going to have to go to our tables for length and area. And in here in length and area, we'll see that there are 2 pages in length and area. And on the first page, page 8, you have a circle and a disc. By the way, the difference is a disc is a solid shape and a circle is just a path around the outside. That's the technical difference. Of course, we're only dealing with the circle and the length around the outside. But that will be all the way around, and clearly we're not going all the way around. Clearly we saw that we're going halfway around. So to get the semicircle from 2 pi r, you divide by 2, which is pi r. Okay, so we have the formula pi times r. We've deduced that. Now if you're uncomfortable with that, I can give you the calculation is 2 pi r over 2, which is 2 pi times. Now, and again, we have to be careful with this 20, and you can see we're constantly reminded we're in the section B, because there's more work there's lots more work being done for everything really. So r is 10 because it's half of the diameter. Diameter is equal to 2 times the radius, and we needed the radius for the formula, so the radius is 10. So now we have 2 pi times 10 over 2, or they cancel, and you have pi times 10. Okay. So we'll do that on our calculator and add 210. Multiplied by pi. Okay, we'll see the digits that we know so well. 3.14 anyway. 159. Most of us might know it there. 31.4159. And we're adding on the 200 and not 210, what did I say? The 110. And we're rounding it down because of that 4. So it'll be 141 is our answer. Okay. Now the distance from A to B is 120. Find the distance from B to C. Find this. Okay, now remember this is 130. So this is a more difficult application of Pythagoras' theorem. So we have 130 here. We have 120 here. And the question is what goes here. So go to our tables as always and look up Pythagoras. Where would we find Pythagoras though? You'd find Pythagoras in trigonometry. I thought I had loaded it in here. I have it in here right now. I'll have to put it in. In a second. So here I'm putting in the trigonometry pages from the formula and tables. Bear with me. Synchronize everything through the cloud. Okay, so here's the trigonometry pages. There are 4 of them, and it's the last of them, page 16, that has Pythagoras on it. Okay, so let's take a look at what Pythagoras tells us. It tells us that if you have a right angle triangle, then the square of A plus the square of B, you can think of that as area sticking out here, equals the square on the red, C squared. Now, but the thing is, we know we're given C in our formula, so this has to be rearranged for us. We're finding A squared, and we know C squared and B squared. Okay. It's a little bit trickier. There's a minus rather than a plus in our formula. So we'll jump back over. Just remember there's a minus to the leg squared. And we'll jump back over and finish out this problem. Okay. So the formula starts as C squared equals A squared plus B squared. And if you did want to use that, you'd be putting 130 squared equals 120 squared plus b squared. And a lot of books will do it this way. Okay, and we will do it this way, and I'll show you the shortcut at the end then. So we could subtract 120 squared from both sides. So you'd get b squared equals 130 squared minus 120 squared. Okay, and then we could evaluate that and then take the square root. And 130 squared minus 120 squared. Okay, which is 2,500. And then we could take the square root of that answer. Now it's disappeared, but you put answer there. You get an answer of 50. B equals 50. But you could have also done it like this. B equals the square root. You could have gone in one single go by using the hypotenuse and squaring it, take away the known leg. And that comes out to be 50 as well. So you can take your pick if you think you're able to know this method for getting a leg. Okay, where there's a minus here. And don't forget, if you're getting a hypotenuse, there'd be a plus here. Okay, but either of them work and the answer is 50. Find the distance from B to C. And as always, go back and look at the question again and make sure you're actually answering the question. And I think we are. So the distance from B to C, a way to write that is this, equals 50. Okay, just to check am I finished? I am. So as always, students, I will see you in the next one.